terrific to be with you, and we've wanted to be on campus for a long time. In fact, my daughter will be at one of the summer seminars this summer. In fact, we were out here in Western Virginia, I don't know, a year or so ago, and saw a sign for Christendom, got off the highway, thought, let's go check out the campus, and got scared. We got out on a 2-lane road and thought, we don't actually know where we're going. It was getting dark, and we actually turned around, so we didn't make it to campus. So succeeded this afternoon. Jake, I want to tell you, when you said you had done background research, I was worried because people often read my Wikipedia bio when they're introducing me. I don't control that. A guy that actually hates me maintains the Wikipedia bio, so yeah, thanks for that. It's all false. Yeah, so I think everything you said was true. Yeah, but what I want to do this afternoon is actually a little difficult. As you might have guessed from my intro, I'm actually a philosopher by training. I'm not a natural scientist, but I talk a lot about these issues. And the reason I do is because of a book I wrote about 11 years ago with an astronomer called The Privileged Planet. And it was actually a book really about science and faith. It wasn't about environmental issues at all, but that got me interested in this question of climate change. And so I started studying it as a philosopher, sort of studying the intellectual issues. And so as a result, I ended up getting called upon when Pope Francis's encyclical came out in June to talk about these issues. And it put me in a very difficult situation. Let me see if I can just sort of describe it to you. I'm a very conservative Orthodox Catholic, a convert of about 7 years. I trust and love the Catholic social teaching and the encyclical tradition. And I disagreed with the Pope on what he said about climate change in the encyclical that I was having to comment on in the media. And I teach at Catholic University of America. So it was a very awkward situation to kind of thread that needle. And so you'll see that here. But what's funny, I don't know how many of you, I won't ask you how many of you have actually read the encyclical. It's very long, it's very detailed. And what you might think is that if you haven't looked at it, there's a sort of section that's like the theology section, and there's a section that's the science section, and then there's a section that's sort of practical implications and suggestions, which would have made people like me and made our job much easier, because the church doesn't claim infallible authority on empirical questions of economics and science or things like that. In other words, the magisterium of the church doesn't have a position on the exact sensitivity of the climate to CO2, right? That's a type of question that's different from the question about the nature of marriage or the nature of the human person. At the same time, popes are perfectly free, both in their sort of personal speeches, in their Wednesday audiences, in encyclicals even, to give prudential judgments about these things. And so as a result, whenever you're reading an encyclical, which is a document of very high authority, to constantly have to figure out, okay, so when in this encyclical is the Pope speaking as Peter with magisterial authority, and when is he exercising prudential judgment about a particular question? And so sometimes if you say read documents from Vatican II, and you'll find comments about things that were happening in politics in the 1960s, it's easy to notice, okay, they were talking about something happening in Europe in the 1960s, but at the time, it can be very difficult, especially if you're an Orthodox Catholic that's not a dissenter, from saying, okay, well, I'm sort of threading the needle here, but just to kind of give away the conclusion, I think everyone that's interested in this issue at least should read Laudato Si and should read it carefully. At the same time, don't expect it to solve every complicated question having to do with climate science. And Pope Francis several times in the encyclical explicitly says, now the church does not claim to specify in advance difficult sort of scientific questions or to settle the debates. But Pope Francis says, but I speak on these things to make sure that the debate is not suppressed. And so what I'll say tonight on climate change is kind of a part of that debate. It's a debate that there are Catholics all over the spectrum on these kind of narrow scientific questions. So what I want to do is not settle that for you. What I want to help you do, and I guarantee you at least this, if you stay with me for about an hour, is I will help you think more clearly about the relevant issues. And I'd argue probably think more clearly than 95% of the population on the kind of issues that are involved when it comes to environmental stewardship and climate change than if you hadn't. That's all I want to do. I'll tell you my opinions on these things. I just want to give you a way of thinking about this stuff so that you can be discerning, so that you can apply Catholic teaching and theology to questions of environmental stewardship, and also kind of think about the economic issues, because you can't really talk, at least in the modern world, about environmental issues and stewardship issues, but I'm also talking about economic issues, because anything we do with the use of resources is going to have some kind of economic implication. So at the end, I'm going to give you a few minutes of what I think the kind of best economic arrangement is for taking seriously the Christian and Catholic call to environmental stewardship. So with that, by the way, I had surgery, about 3 weeks ago, I think, and so it actually was on one of my lungs, and so I may have to actually stop and catch my breath a couple of times. It's not what I normally do, but if I have to just literally stop and catch my breath, that's what's happening. So don't think, is this guy about to pass out or something? That's all that's actually happening. All right, so we're going to start with theology. Then we're going to have a kind of heaping helping, not of science, but just kind of a thinking about the scientific issues, nothing super complicated or technical. And then a kind of practical implications, all right? Well, so a lot of people, especially a lot of Christians that don't pay any attention to environmental issues, in fact, a lot of my evangelical friends, very conservative, say, look, I mean, isn't this whole environmental thing just kind of a lot of hokum? I mean, why should we even be concerned about environmental issues? And you get this impression if you sort of listen to a lot of people that appoint themselves as environmentalists. In fact, a lot of them actually tend to be anti-family, they tend to be anti-human. I can give you a long list of quotes from self-appointed environmentalists that actually think human beings are parasites on the creation. How many of you have seen this TV ad by Julia Roberts? So Julia Roberts is the voice of Mother Nature, and it's sort of beautiful images of Mother Nature. Have any of you seen this in the last few months? So it's her voice, right? She's speaking as Mother Nature, and she's essentially saying, I don't need you, human beings. I've killed whole civilizations, and I'll destroy you all eventually, and I'll still be here. I'm not making this up. This is literally what she says. And I thought, okay, this is not the kind of thing that I would think would warm up people that are skeptical of environmentalism, right? This is not going to kind of sell you on it, right? And so the encyclical actually, it's clear that Pope Francis was concerned largely with this problem. One, that environmental issues he thinks are very, very important. Two, that Catholics in particular ought to take these things seriously. And three, environmentalism, as it's been branded and articulated in the public consciousness, is essentially kind of an anti-human ideology. And he argues in the encyclical, one, that's actually a really perverse way of thinking about the environment. But if you just think about this logically, if we're called to be responsible stewards, right, of the environment, how coherent is it to say that human beings are utterly insignificant? What does it mean to be a steward? A steward is someone who is placed in responsibility over something from someone else, right? So if we're supposed to be stewards, that means someone has put us in charge of the created order and will hold us responsible for how we're acting. Look, if we're just the result of blind and purposeless chemical processes, this makes no sense at all. In fact, I would argue the concept of stewardship doesn't even make sense in a materialistic worldview. It actually makes a heck of a lot more sense in a theistic and a Christian and Catholic worldview. And so that's kind of one of his points in the encyclical, and I think it's one of the most important points. We have all we need as Catholics to mount and to frame a robust environmentalist ethic that takes the creation seriously and takes human beings as creatures made in the image of God and as stewards seriously. So I'd argue actually the Catholics have a much better grounding for getting a balanced environmental theology and ethic than anyone else. And I think Pope Francis agrees as well. So I could spend an hour on the encyclical, I won't do that, but it's sort of three main themes I would say to anyone that says, why should we care about this, are also themes that Francis speaks of in Laudato Si. The first is just simple human well-being. He emphasizes over and over that human beings, yes, we're creatures made in the image of God. God, when he creates Adam, remember, he breathes into him the breath of God. But what does he do before he does that? God takes the dust of the earth. So yes, we have the breath of God in us. We're spiritual beings. We're also material beings made from the slime of the earth, as Thomas Aquinas says. So we are always both physical and spiritual. We are a part of the created order. We're unique in that we're created in God's image, and we have a unique rational and spiritual component, but we're always at the same time physical beings made of chemistry. The laws of chemistry actually apply to our bodies, right? If you have too much beer tonight, that will apply directly. We know how that works, right? And so what that means is that just simply thinking about it at a physical level, if we do something to destroy the natural environment that we're a part of and that we depend on, we are going to be harming human well-being. And as Christians and as Catholics, we ought to be interested in human flourishing, and in particular, the flourishing of the poor. And very often if you go to poor places, you go to poor countries, you don't just see a lot of poverty, you see a lot of environmental degradation, really basic environmental degradation that we actually don't know anything about. There is probably not a city in the contiguous United States that you could go in, turn on the tap water, and drink and get sick. We take this for granted. But until the 20th century, and now even in the 21st century in most places, and for most of human history, there was nothing like that. The majority of people were dying of cholera and typhoid and really basic environmental pollutants. We've long since solved those kinds of environmental problems, but that's what a lot of the poor, especially in the developing world, still have to deal with. And so, first of all, we got to be interested in human well-being. If you're interested in human well-being, that's all you're interested in. You still got to be interested in something having to do with the well-being of the natural world. That is at least the natural world, of course. Think of it as the sort of surface of the planet 10 miles below and 10 miles above it, right? We don't really have stewardship over the entire created order. I mean, we can't really do anything to affect Alpha Centauri, right, or the Andromeda Galaxy. So God has purposes, as he tells Job, right? What does he say to Job at the end of the book? God shows up, he says, where were you? Look at the Pleiades and Orion and Behemoth and Leviathan. Point being, I have all sorts of purposes and I've created all sorts of things that you don't have anything to do with and you know nothing about. Right? And so it's good to be reminded of that. It's also good to be reminded of the fact that God, when he places Adam and Eve in the garden, he tells them to till and to keep it. And then what does he say? He blesses them. This is at the end of Genesis 1. And what does he say? It's a blessing and a command. Be fruitful and multiply and fill the earth and subdue it and have dominion. Right? Over the fish of the sea and the birds in the air and every living creature that creeps upon the earth. So we're called to have dominion. But dominion in the biblical sense is not domination, it's not destruction. This is a problem. If any of you have ever taken an environmental ethics course, any place but Christendom College, you probably have read an article by a man named Lynn White in the late 1960s. And White blamed what he called the ecological crisis at the time on the biblical understanding of the human person. He said, we will never solve our ecological crisis until we abandon the biblical idea that creation was made simply for the purposes of man. Now, if you read the Bible, it says nothing like that, but a lot of people actually believe that. It's the biblical idea that the created order is made simply for human beings to dominate and do whatever they want. The biblical idea of dominion is, remember, it comes derivatively. Adam and Eve exercised dominion or stewardship on behalf of God. So our dominion over the created order is a reflection of the benevolent dominion of God. So it has to reflect that. It doesn't mean domination. And that's why we tend to use the word stewardship. Dominion in the proper biblical sense and stewardship are more or less synonyms. But because there's so much confusion, we tend to use the word stewardship. And all these things go together. And so I think probably the most beautiful thing about Dr. C is the way in which Pope Francis connects human well-being and the well-being of the natural world and the planet in a way that makes it very difficult to kind of disentangle these things. So all that stuff is true, all that stuff is important, and all that stuff makes it really useful and powerful for us to develop an environmental ethic that takes the natural world seriously as our responsibility, but also takes the human person, and as he emphasizes, the natural order of the human family as a part of God's created order, so that you don't move in this other direction in which you treat the human person and human beings as if they're the problem rather than part of the solution. And so that's what makes it very powerful. All right, so just think of that. Notice I haven't said anything about the climate change issue. And if we had talked about environmental issues in the 1960s or 1970s, climate change as we think of it now, we wouldn't be talking about it. We would be talking actually about pollutants, things like lead, sulfur in the air, sulfur in the water, actual pollutants in the sense of poisons that at certain levels in the environment become actually deadly toxins, right? That's what we mean by pollutants. We don't talk about those things a lot, not because there are no pollutants anymore, but because we've solved most of those really severe problems already, at least in the West. In fact, the water in the air now are vastly cleaner, orders of magnitude cleaner than they were just in the United States, say in 1970, when around the time I was born. So we made huge progress there. But as a result, this issue of global warming and climate change has in some ways kind of sucked all the air out of the room when it comes to talking about the environment. And so instead of talking about, so there's still real problems with gill nets and overfishing certain parts of the sea and things like that, almost all discussion of the environment has to do with this question of climate change. And I think that's unfortunate. And the reason is, whatever you think of the effects of carbon dioxide and the use of fossil fuels on the environment, carbon dioxide is not a pollutant. It's not a toxin, right, in the same way. It's a natural part of the atmosphere. Of course, we're expiring it continuously. Nobody thinks, you know, we're not breathing out a pollutant in the same way we would be if we were breathing out lead, right, or sulfur dioxide or something like that. So the reason it becomes an environmental issue is not because it's a pollutant, but because of at least the hypothesized effect that it's believed to have long-term on the global climate. So that's the kind of first distinction I want you to make and to try to remember. The difference between environmental issues having to do with pollution and environmental issues having to do with climate change. Does that make sense? Don't think of carbon dioxide and greenhouse gases like water vapor, all right? Water vapor is the most powerful greenhouse gas. That's not a pollutant as, say, lead in the water or the air is, all right? Or carbon is. Carbon in the air, carbon black, that's an actual toxin and a pollutant that's different from carbon dioxide. These are two completely different things. So what is climate change about? As I told you, I'm a philosopher, I'm not a scientist, so I sort of take this issue and say, okay, what exactly is being claimed? What's the evidence? And what should we conclude? And here's kind of the basic idea of climate change. Climate change is not different from global warming, but this is sort of how I think about it, is the main predictions of climate change are an increased warming of the planet. But the prediction is that you'll get an increased warming of the planet as a result of greenhouse gases that essentially trap heat from the sun. And as a result of this warming, you'll get other types of change in the climate. So you get increased droughts, much stronger and more frequent hurricanes, things like that, that you don't directly think of as having to do with the temperature, right? But greenhouse gases increase the average temperature of the Earth that leads to other kind of bad climate things that'll happen. Now, there's also a kind of trick that can sometimes go on here, because when you're talking about global warming, you're kind of clear what that means, right? Okay, let's look and see if it's actually getting warmer year on year or not. Climate change can kind of mean anything. And so this is as a philosopher, it's where I get a little squeamish with scientists talking this way, because literally anything that happens ends up being evidence of climate change, right? So literally whatever happens tomorrow is an example of that. And for scientific theories, you usually don't want every piece of evidence and its opposite to count as evidence of the theory, right? I mean, that's kind of a fun theory to have because nothing counts against it. But the idea is that if you're going to make a real sort of predictive hypothesis, you'd want something to count against it. The good news is that the prediction is still for increased warming, so we can directly test that. But it's not just that, right? In fact, just to say that, well, we're in a warming trend and we don't know what's causing it, and there's nothing we can do about it, that wouldn't even probably be a subject of conversation in environmental questions because there's nothing we can do about it, right? So the first claim is that we're undergoing warming on average. The planet's on average getting warmer. Second is that it's largely induced by human beings, all right? So that it's largely the result of things that human beings do. And the third thing is that it's catastrophic, right? If you don't have all three of those things, it doesn't become a really important environmental and political issue. If we're just kind of slightly warming the Earth, and it's a good thing, right? It's not going to the UN's not going to probably need to be involved, right? But if it's human-induced, we're the primary cause of it, and it's catastrophic, then it seems that, okay, that's probably something that we need to do about it. So when people say, well, do you believe in climate change? It's usually all three of these things. But you can see already, right, that these are logically distinct ideas, right? You could think, well, yeah, maybe I think there's evidence of this. I don't know about this, and I doubt this. In fact, there's what, about 9 logical possibilities, or really more if you split it up, of opinions you could have. And so already, under climate change, we've got multiple distinct logical ideas and claims being made. All right, but you can see that they always get bundled up together. This is a cover story. Every April, of course, is Earth. There's kind of an Earth Week and an Earth Day, and so all the main publications do now global warming stories. And this is from a few years ago, Time magazine. Notice the way that the text and the picture work together to give you the message. Right? It says, be worried, be very worried. Now, if you just saw that picture of the polar bear by itself, right, without context, what would you think? you were looking at, right? You had no context, look at him. Try to just look at the picture. I can tell you, because I looked this up, I know actually the origin of the picture, but you can almost see it just by looking. What do you think that polar bear is doing? And what the editor wants you to think is what? What's he?
That it's looking to continue walking.
Right, that he's sort of trapped on the edge of the ice and doesn't know where to go and is going to have a long swim ahead of him, right? Okay, now what's another possibility for what he's doing?
Fishing.
Waiting for the seal to come up for air, right? Yeah, and that's in fact what he is doing. And so you can see how the different ideas get bundled together and they circumvent our kind of rational faculties. Another great image is a picture, you look it up online, and it's a picture of an iceberg with a sort of lower level, and then it's got this kind of thing that sticks up like 15 feet. And so there's some polar bears on the bottom, and there's one up on the top. And it was used in the same kind of context for a different magazine. And the photographers from New Zealand protested that one. And the reason is because they were taking pictures of these polar bears climbing up, jumping into the water, diving in, and then climbing back up and doing it again. They're literally playing on this iceberg above the Arctic Circle, and the magazine interpreted it as they're just sort of stuck on this little piece of ice. So just that's kind of a side lesson in how to sort of think critically about these issues. All right, so what's the argument? I mean, the argument for this, there's all sorts of very complicated technical, physical, and climatological issues involved in climate change. And in fact, there are no experts in climate change because it's such an interdisciplinary question that people are experts in things like dendrochronology. Anybody know what that is? That's the study of tree rings and trying to reconstruct the climate based on tree rings. Well, you know, that doesn't make you a really good physicist or a really good biologist. So this is the problem with this issue. And this is also my apology for why philosophers should think about it, because it's so interdisciplinary that very often people don't think clearly about this issue. But here's the basic argument, and it's not at all complicated. Here's the first premise. Increases in carbon dioxide and other greenhouse gases lead to a greenhouse effect. I won't go into the science here, but this is very well understood. 3 atom molecules like methane, water, at least in its gaseous form, and carbon dioxide. So these molecules are 3 atoms. There's a particular effect with infrared light or energy from the sun. And you can just think of it simply as these molecules being really good at trapping infrared radiation. I mean, that's not exactly what's happening, but just think of it that way. So that's what makes these things greenhouse gases. So a greenhouse is, of course, it's a little glass structure that holds infrared radiation, and so it's warmer than the surrounding environment. This is well understood. We know that if we didn't have an atmosphere, the planet would be at least 30 degrees Celsius colder, which would make it, that doesn't sound that bad, but it would make it uninhabitable for human beings and most metazoans. There'd be, like ice-dwelling bacteria and stuff, but I mean, who cares, right? I mean, none of the really interesting stuff. So it's very good that we have a greenhouse effect and we have an atmosphere. The water vapor is actually by far the most important one. By itself, carbon dioxide is a trace element that's between 300 and 400 parts per million in the atmosphere, and then methane and some others. All right, so that's well understood. Also, it's well understood that we've been adding carbon dioxide to the atmosphere during the beginning of the Industrial Revolution, most in the last 3 decades or so. That part's uncontroversial. Second, the temperature has risen during the 20th century while greenhouse gases have increased due to human activities. All right? So we know the effects of greenhouse gases. The temperature has gone up at the same time that carbon dioxide has been being added to the atmosphere. Now, some of you, I'm sure, or most of you have had philosophy here or logic, and so you know that correlation doesn't prove causation by itself, right? You can have 2 things happening, like the use of cell phones has gone up, right, at the same time that carbon dioxide has gone up over the last 10 years. But you don't actually think the CO2 has caused the increase in cell phone usage, right? That's just mere correlation. But here, because of the understanding of the chemistry of carbon dioxide, the assumption is that that increase in the atmosphere is causing the warming, all right? So this is not a crazy conspiratorial idea. And so this is the conclusion. Therefore, probably greenhouse gases are the cause. And AGW just means anthropogenic global warming, human-caused global warming. Really simple stuff, right? The simple kind of straightforward logical argument. All right, now this is the part I told you, if you can remember these 4 questions, whatever else you learn or remember or forget about this issue, you will think more clearly than the vast majority of your fellow Americans. And that's fun, right? To just be able to, you're at a cocktail party and you realize, actually, I think more clearly than you do, right? It's a great cocktail party conversation. Actually, you don't bring it up. It's a kind of private pleasure, but you don't want to bring it up in conversation, right? And here's the basic 4 questions, all right? So just as this, notice there are logically separable issues, there's logically separable questions, and you can answer them in different ways. Question 1, is the Earth warming? All right? That's an empirical question. What's actually happening? We study what's happening, say, over the last 40 or 50 or 100 years as well as we can. What's the actual evidence say? It's a straightforward empirical question. The second question is different. It's a causal question. Are we causing or contributing to it? Right now, you could have all the warming in the world. You could have the polar ice caps melting. You could have, right, the polar bears all drowning. Every possible evidence of warming available, and you still wouldn't have the evidence for the cause. The empirical question about what's happening and the causal question, what's causing it, those are logically separate questions. The third question is the one you almost never hear. Is it bad? Right now, this is the question you're not supposed to, you don't bring up this question at a cocktail party. Trust me, I've tried it. And it's like you said something racist, right? Because this is just not supposed to be said. But it's obvious what you pointed out, right? Okay, it could be warming. We could be causing it or mainly causing it, and it could be good, right? In fact, I'm going to leave that with you for a while because we'll come back to it. But the fact that the question isn't asked more often to me is a sign of suspicion. And then number 4, would the advised policies make any difference? Right? It might be warming, we might be causing it, it might be awful and catastrophic, and we might actually have no realistic way of solving the problem. All those things are possible. Right? So there's a heck of a lot of possible answers here. So if somebody wants to sort of get you to answer what your opinion on this issue is, based on a yes or no, when you know there's this many kind of separate issues, you realize, okay, it's really kind of an unfair question. So let's go through it really quickly. I'll just give you my strongest opinion. I think it's a sort of educated amateur's opinion on what's happening on all these questions. So the questions are different from my answers, obviously. I think that we're in a gradual warming trend, and what I'm saying here, I'll tell you when I get to something that's controversial. What I'm telling you here is not controversial. In fact, most people involved in the debate would agree with this point, that we're in a gradual warming trend that started around 1850 of about 1.5 degrees Fahrenheit, or about 1 degree Celsius. I've got 0.8 degrees Celsius here, right? And so this is just data from 2 different sources. The Hadley Center is the UK center that studies these things, and the Goddard Institute for Space Studies, an American one. So it shows this trend from 1850. It looks significant, but notice the scale here, or in sort of tenths of a degree. So that's a gradual warming trend, and it's since the beginning of the Industrial Revolution. There were things happening prior to 1850, but we weren't in any significant way contributing CO2 to the atmosphere. So that's where most folks start. All right, so I think, okay, if you are just talking about that, yeah, we're in a sort of gradual warming period. But even here, we get kind of complicated. Most of you have probably heard that there's this weird pause that happened from about 1998 until this year, actually. 1998 was an El Nino year, which is a complicated climate in the current in the Pacific that leads generally to warmer temperatures, abnormally warm temperatures. That happened in 98. It looks like we know we had an El Nino year in 2015. All the relevant models that are relied on to predict what the climate was supposed to do had predicted a great deal of warming. None predicted that for better part of 20 years, the global climate would just freeze. And so there are about, at this point, 150 attempts to try to explain why that happened, but none of them were a part of the original theory. What happened is that virtually everyone predicted based on models that we're going to get significant warming. It didn't happen, and so after the fact, you come up with a story to explain why the data doesn't fit with the theory. All right, so no one expected that. Also, look at a little perspective. It's one thing to say that we're in a warming trend since 1850, but you might, if you're thinking carefully, you might think, okay, 1850, that wasn't the creation event, right? I mean, there was stuff that happened before that. What was happening before? Well, here's a sort of simplified schema of what's happened just since the last ice age, all right? So So guess what? It was way cooler during the Ice Age, right? So we've basically been in a serious warming trend since the end of the last Ice Age. Most of the warming here was within a few thousand years from the present. Most of it's interesting human history that's happened here. And what do you notice just from glancing at this? So that over there on the right, let me just go over here. Right here. All right. That's recently. All right. And so if you were thinking that we have radically a serious catastrophic warming that's unprecedented for human history or for geological history, what do you notice from looking at this? There's warming periods in fairly recent history that are at least as great, if not greater, than the current one. The medieval warming period of 1,000 years ago is probably when the Vikings settled Greenland at the time. I assume they called it Greenland for a reason. It's actually warmer then. It was probably warmer during the time of Christ, a period that's called the Roman climate optimum. In the Holocene climate optimums, it was even significantly warmer. You notice that there have also been significant sort of dips. What's after the medieval warm period, there's a period called the Little Ice Ages that continued up through the American founding. So all I want you to see here is that the amount of warming we've experienced since the beginning of the Industrial Revolution is well within natural variation. So it is very hard, just simply logically speaking, to separate out the signal from the noise. That is, if you think of natural variation, what the climate normally does, right, it already varies a lot. And so what you're trying to do when you're going to sort of solve this question is you want to say, okay, can we detect the human signal given the background of natural variation? And as long as a contemporary situation fits within the variations of natural history, it's very hard to separate the signal from the noise. So I think it's quite plausible that humans are contributing to climate change and warming because CO2 is a greenhouse gas. It's actually really hard to nail that down, how much or how significant it is. All right, so number 2, are we causing it? This is the one everyone's interested in, right? And this, I think, is probably the hardest question. Now, this is going to be the most technical point, but it's something you probably do not know. It's also completely uncontroversial. In September, the CUA was asked to do a conference by the Bishops' Conference on Laudato Si, and they asked us, I'm in the business school at Catholic U, and so they asked us do a panel on the science at the beginning. And so emails, something happened, a piece of paper got lost, or somebody got confused and asked me to be on the science panel, all right? So I was sort of surprised. Did they Google my name? I'm surprised they asked me to sort of talk about this. And so there were people of widely varying opinions on the science, needless to say, at the conference. And I mentioned this. No one disputed this, all right? This is a well-understood fact in the debate, but most people don't get it. What most people assume about the warming effects of carbon dioxide is that each additional increment of carbon dioxide sort of increases the warming, right? That it's kind of a runaway greenhouse effect so that each additional molecule is going to make the warming more and more and more dramatic. Turns out it's exactly the opposite. It's an extreme diminishing effect. It's a logarithmic effect. And so it's essentially this, and this is well understood, you can test this in the lab, is that you essentially get, if you're just thinking about the effects of carbon dioxide, so forget the other parts of the climate, right? We're just talking about carbon dioxide. For every doubling of carbon dioxide in the atmosphere, you'll get about 1 degree of warming, right? For every doubling. If you think about that, that means, right, it's going to be harder and harder and harder to add an additional 1 degree of warming, right? In fact, the vast majority of the warming would already be in the system by what we've done, right? So add, say, 400 parts per million. We've added about 100 parts per million in the last several decades. But you'd have to add another 400 to get 1 additional degree of warming, and then 800, 1600. You see how it goes, right? So it's an extreme diminishing effect in which you essentially you saturate the system with CO2 and it doesn't have any more greenhouse effect. So now you're wondering, okay, now so why are people worried about this, right? This is not, what I've told you, it's sort of basic understood physics. The reason is because it's assumed that there are also various feedback mechanisms in the climate, so that CO2 is not just working by itself. What it does is it becomes a trigger of other effects that are very significant, all right? So this is why a trace, assuming this sort of theory, you can have a trace gas like carbon dioxide that by itself would not induce very much warming, But if it induces other processes, could lead to significant warming. That's what's going on. It's sort of like an enzyme in your body or a hormone, right? Very small amounts of particular anabolic steroid, for instance, at least with males, can have very significant macro effects. It's because it's triggering other things. And this is where almost the entire debate is. If you think, okay, there's a huge sort of diversity of opinion among scientists, among policy people, having to do with the climate change debate, 95% of the question is on this one question. How significant are the feedbacks, and how many of the feedbacks are negative, and how many of them are positive? Or as it's put technically, how sensitive is the climate to additional CO2? How sensitive is, in other words, does it not do very much with additional CO2s? Or is it like a sort of house of cards, and it's very, very sensitive? And this is where the entire debate is. Right? You think it's all over the place, and literally this is what it is, but there's so much rhetoric about the issue that people mostly don't know this. I won't ask you how many of you knew this, but it's literally this question. It's the question of feedbacks. So all most, if not all of the models that are used by the Intergovernmental Panel on Climate Change, that's the UN body that studies this, they use models, computer models, to sort of predict what the climate's going to do. So they have to plug in assumptions right at the beginning. They all assume that virtually all the feedbacks are positive. So what that means is in a positive effect, that means that you do something that enhances the effect. And negative feedback means that it mitigates it. You know, I'll give you an example of something that you're familiar with, your metabolism, right? Now, at least I can sort of describe myself in high school. So I was a little heavier now, but in high school I ran track. In my sophomore year in high school, I was 6'2", 135 pounds, right? So it drove me crazy. I couldn't figure out how I'm going to put weight on. I ate whole pints of Haagen-Dazs ice cream. Nothing, right? How is it just, this doesn't make sense, right? It's just basic chemistry. What was going on here? Anybody know what's happening? How is it that I could ingest 10,000 calories and I stayed exactly the same weight? Anybody know what was happening? What was happening?
Does the body kind of have like some kind of homeostasis?
Yeah, that's what metabolism is. Your body adapts, and it gets worse and worse at this, incidentally, as you get older, unfortunately. What happened is my body just increased the amount of energy it used, right? So it just jacked up my metabolism and burned more calories. It refused to add weight, right? Well, the climate, that's how feedbacks work, right? And so in that case, what my body had was a negative feedback, right? If I ate more calories, it just heated up and burned more calories. It wasn't doing anything. So the whole question about the climate is what's happening with the feedbacks, with the clouds, with the ice, what's happening with land and grass and the oceans. Are they feeding the effects, or are they mitigating and reducing them? That's the whole question. All right, I can spend hours on that, but I won't because it would bore everyone to tears. But I want you to know that's where the real debate is. Here's the sort of meat, though. But as I told you, the models, I reduced this as just the 44 most recent models, but there are about 100 computer models, very complex server-eating models that simulate what theorists assume is going to happen with the climate. There's about 100 of them. These are the 44 latest. And so you can see the kind of spaghetti lines that go up. Those are the predictions of the models regularized back to 1975. And what you notice, what do you notice? This is the average of the models right here. Right, and the red and the blue lines are the two most reliable satellite data sets that we have. What this shows is that the models predict about twice the rate of warming that's actually been observed. All right, so the models said the climate's really sensitive to CO2. The observations from the best data from the satellites says, well, that's not what's happening. There's still a little bit of warming going on, but that's just not what's happening. So I say, based not on, I'd say what needs to happen is that the models need to be rebuilt to take account of the actual evidence. So that's why this is getting heated, because the longer it goes on, the wider the space between the observations and what's actually happening and the predictions of the models are. And so people that are committed to the models get more and more desperate as the space between what's actually happening and what they had predicted would happen get wider and wider. All right, so that's, I've given you all of by far the most technical stuff. So now let's get to the kind of fun stuff. Remember question number 3, is it bad? Now how would you answer that question, ultimately? You'd have to know something. You'd have to know what is the optimum global average temperature? What is it? If you know what it is, right, then you can say, okay, so what's happening and you would know if you're getting closer to it or away from it, right? But if you don't know what it is, it's very hard to answer this question. Now, of course, we know it's somewhere between 0 and 100 degrees Celsius, right? I mean, this is sort of obvious. But we don't actually know that the optimum, at least for most types of life and for human flourishing, for all we know, it's slightly above where we are now. In which case, a slight warming would actually be better rather than worse. But in the public debate, it's overwhelmingly treated as if it's always an unmitigated bad. Now, what's funny is that even the Intergovernmental Panel on Climate Change, so the UN Committee, if you read their most recent report, although they're worried about the sort of decades out, say actually the recent warming, the warming of the next few decades, is probably more good than bad. That's the UN, but almost no one really realizes this. All right, and I don't want to solve that for you, I just want you to see it's actually kind of an open question. There's some other things, and you might have heard about all these sort of catastrophic predictions: dramatic sea level rise, increased hurricanes and tornadoes, shutdown of ocean circulation in the Atlantic, right? The melting polar ice caps and the polar bears, droughts and all this stuff, all right? But the problem is that what we're dealing with here is predictions of what is supposed to happen. If you look at the actual trends, none of this stuff's happening. Now, you get news stories about it. If you look at the actual data, I'll just give you a few. All right, so this is the global tropical cyclone, so the sort of power, the cyclone energy. Since 1970, no trend. The global tropical cyclone frequencies and how frequent these are. So basically, if you're in the Pacific Ocean, you're a cyclone. It's not exactly this way. It's a hurricane in the Atlantic. It's very complicated, but it's basically the same thing in different places, all right? No trend. This is global hurricane frequency updated in 2014. No trend. I could show you a bunch of these, but it gets boring. The point is that none of these things is predicted shows any actual trend so far. Theoretically, if we reach a certain rate of warming, some of these things are supposed to happen. The theoretical underpinnings of this idea itself are questionable, though, because if you think about it, one of the main predictions of global warming theory is that most of the warming will take place on the poles rather than the equator. So if that happens, that means there's going to be less difference between the temperatures on the poles and the equator, which would presumably lead to fewer and less intense hurricanes rather than the other way around. And so there's some kind of theoretical dispute about that, even if you sort of buy the theory, right? All right, I won't spend a lot of time on that. The other thing is, of course, CO2 is plant food, right? You know this. In fact, plant growth completely stops if we went down to about 250 parts per million in the atmosphere, plants would cease to grow. NASA just today released a study reporting on this, that in fact, as I'll show you in a minute, there's actually been an increase in the greening of the planet over the last several decades, primarily as the result of increases in CO2. This is actually a picture of a scientific group in Phoenix, or in Arizona, and what they do is they put different kinds of plants in these little greenhouses, and then they inject different amounts of CO2 into the atmosphere and discover what happens. Guess why? Different plants respond differently, but in general, plants do better and grow much more quickly and are more robust the more CO2 you have in the atmosphere, right? So that's actually a positive thing. And as I mentioned, this greening of the earth, I don't like this picture because this scientist, I swear sometimes, so this is just their figure. So the red actually shows more greening, right? So over the last few decades. And so if it's red, in your mind, you're supposed to think, oh, it's gotten greener. Right now, can you imagine this? That no graphic designer said, don't use red. Okay, so somebody else figured this out. So this is the data from Liu et al., 2010. And this is a much more recent one, and they figured out, let's use green. And so what is this? And so it's an analysis of what's called the leaf area index. And so you can do satellite analysis, just spectral analysis of how much green there is on the planet and whether you're losing it or not. And so you can see over here, so the sort of dark blue spots are places that have, in which it's gotten less green, essentially, and then the yellow and the green are places where it's gotten more green. You can see the trend, right? This is from data in 2013, and I mentioned just this morning, NASA released a study. So as the CO2 increases, the planet is actually getting greener. This is one of the most underreported stories, I think, of the century. All right, then finally, number 4, would the advised policies make any difference? And this is actually where I've spent most of my time. So let's assume Forget everything I've told you and just assume it's getting warmer. It's continuing to get warmer globally. We're causing it by our activities of using fossil fuels and releasing carbon dioxide in the atmosphere, and it is absolutely catastrophic. What would we do about it? Right? And so to actually do this at a policy level, the first thing you have to do is you have to weigh all the costs and benefits, right? So any kind of change is going to probably help one person and harm somebody else. Just like any climate change might lead to a drought in one place, but warmer and wetter climate someplace else, increasing a farming season, for instance, or something like that. And so to figure out those things, you actually have to weigh all the costs and benefits. And because to do that, what you want to say is, okay, well, if the costs of any particular policy are so dramatic and the benefits are so low, then what you want to do, rather than trying to stop what's happening, you figure out how to adapt to what's happening. And a lot of economists that have studied this issue have said, including economists that are catastrophists, say we're much, much, much better off learning to adapt to whatever happens than trying to stop it. I'll just give you one example from the Kyoto Protocol, which is the previous UN treaty that was in place until just a few years ago. So what the Kyoto Protocol did for people that signed it was that countries agreed to reduce the amount of greenhouse gases, or CO2, to 5.2% below the levels they were using in 1990. So basically they were saying we're going to reduce the amount of CO2 to a couple of decades ago, right, which would have been quite substantial. The United States did not sign this. It was shot down 95-0 during President Clinton's presidency when Al Gore was the moderator of the Senate. All right, so the US was pilloried in the international media for this. And yet not one country that signed it actually complied, not one. All the preening Germans and French that signed it didn't do it. In fact, the United States, we actually reduced the intensity, it's what's called the sort of intensity of our use of carbon fuels during this time. What's funny is that the economists at the UN that analyzed how much this would have cost figured out that if every country that signed it had complied and the theories were right, 50 years out, it would have reduced warming by 0.05 degrees Celsius, which is statistically undetectable. Right? So if everybody had done what they were supposed to do, it wouldn't have done anything significant, and it would have cost $10 to $50 trillion. $10 to $50 trillion. Same group estimated at the time that we could outfit the rest of the world with clean water technology for $200 billion. All right, so that's the perfect example of all cost and no benefit. Just 2 weeks ago, the same analysis was done of the Paris Agreement, which is even weaker than Kyoto, and it's the same thing. It's basically a few points of 100, between 5 and 7 hundredths of a degree reduction in warming if everyone did it. And I promise you, no one is actually going to comply because there's no kind of compulsory mechanism in it. And so a lot of it, the point is, no politically realistic policy is likely to do very much significant, even if you think it's catastrophic. And so what we need to do is turn to mitigation strategies. And so what I would say this way, even if the worst sort of scenario is true, what is the best thing to do for human flourishing in the future? So let's assume that we're going to get 2 degrees Celsius of warming in the future. We know this. The richer you are, the easier it is for you to adapt, right? We've got air conditioning in here. It's not working very well, so we've got the windows open, right? But you know, if you live in sub-Saharan Africa in a hut, right, and dung is your primary source of fuel, there ain't a lot you're going to do if the temperature changes, right? A drought can be deadly. We don't die of famine in the West because we can adapt. And so what we should want, because we know even if we're not causing it or we are causing it, climates change, things happen. And so what we want is for the part of the human population that's not as well off and as wealthy as we are, we want them to be able to adapt as well as we can, whatever happens. And so that leads finally, I think, to this question. What system best allows us to adapt? And I can spend a bunch of time on this because this is kind of my issue, but just a couple of sort of details in case you thought that with the sort of increase of industrialization, the greater use of resources in the 20th century, that we're using all these things up. If we're using up all the commodities, what would be happening to the prices? We're using up all the gold, we're using up all the aluminum, the copper, and the oil. Prices would be going up, right? Well, this is the commodity index from 1934 to 2013. As more humans have occupied the planet and more humans are using the main commodities, the real prices of commodities has gone down rather than up. That's weird. It doesn't mean that they're sort of infinite resources. It's because we developed technologies that allow us to use these things in different ways and to discover more. But that's often surprising to people, and that's true even given radical industrialization. And then the other obvious thing is it's in the developing world and even in the still developing world, on basic metrics, life expectancy, right, infant mortality, basic access to health care, access to calories, human life has vastly improved in the 20th century. At the same time, that the increase of carbon dioxide in the atmosphere has gone up. And those things, when they've happened, have happened generally most intensively in societies that we could call economically free. Now, interestingly, you might think none of this stuff's happened even in sub-Saharan Africa, but if you compare life expectancy in sub-Saharan Africa in 1900 and in 2000, it's actually gone up quite significantly. It's just gone up much, much, much more significantly in the developed world, primarily because we've almost eradicated infant mortality. So, you know, I mean, even in biblical times, right, people could live to 80 years old, but the life expectancy was about half what it is now because so many people died in childbirth and just after childbirth. So now we turn to sort of the question of the environment and free economies. I don't know if you guys can see this image or not. It's sort of an outline of a land mass. Does anyone recognize what this land mass is?
Is that South Korea?
It's actually the Korean Peninsula. You said South Korea because that's the only one you can see. All right, so let me move over here. There's a little outline right here. You barely see. That's North Korea at night from satellite. Right? So if you're an astronaut, you're thinking, man, I'm moving to North Korea, right? There's no light pollution. Now think of the Korean Peninsula. Right? It's ethnically homogeneous, has the same climate, it has the same soil. North and south, it has the same history. In fact, it's probably the most ethnically homogeneous part of the world. And in fact, it had the exact same history until the 1950s. It was almost entirely agrarian peasantry, people sort of subsistence farmers. So what's happened since then? Right? Now, South Korea is not a perfect example of rule of law and market economy, but it's not a bad example. It's had industrialization, relatively free markets, especially recently, relative maintenance of economic freedom and rule of law. Oh, you've had the final Stalinist state has been maintained since the 1950s in the North. I love this example because it's a perfect example of what simply economic and political policy can do to a society in a few decades. That's the only difference between these two places. If you study for the last 20 years, the Heritage Foundation has developed, it's based on a series of metrics, something called the Index of Economic Freedom. Index of Economic Freedom, and it ranks essentially all the countries for which we have data, 180 countries, with respect to rule of law, how easy it is to start a business, these kinds of things, just in terms of their economic freedom. They always rank the countries every year. And every year since I've been following this, Hong Kong, which is still treated as its own country, is number one. And guess what the last one is? It's North Korea, right? And so that kind of tells you everything you need to know, kind of a simple back-of-the-envelope calculation for the effects of economic freedom. Economic freedom doesn't refer to people doing whatever they want to do, right? If you've been reading Ayn Rand or reading the anarcho-libertarians, you might think economic freedom, that's just where everybody does what they want to do, right? No, that's not what we mean by economic freedom. That's called anarchy, right? So if you want to know what that looks like, read The Lord of the Flies, right? So anarchy is the law of the jungle, the powerful lord over and prey on the weak. Economic freedom exists where you have rule of law, private property rights, a functioning banking system, detailed and enforceable property, an entitling system, robust civil society, things like that. So you get a certain set of conditions that sets up conditions for economic freedom, for people to be able to buy and exchange goods and services with each other without sort of undue interference from others and from the state. You set up a situation like they enjoy to some degree in South Korea and that they don't enjoy at all in North Korea. Now, that's a brief kind of case for economic freedom. We're talking about environmental stewardship, right? So the question is this. If you looked at the same index and said, okay, so how is the environment, the local environment, environmental policies in these different countries? You'll discover two things. I just checked this morning. One is that countries early in the stages of development are hard on the environment. If you want to know what that smells like and looks like, go to Guangzhou, China, in the middle of the day. You can see it in the air. China's at an earlier stage of development. Go to London in 1905, right, or Liverpool, when everybody's burning coal in their chimneys. So early in stages of development, industrialized countries are hard on the environment, and countries at higher stages of industrial development are very good on the environment on every possible indicator. Now, why is that? I just found this morning and dropped it in because it just came out. This is actually an analysis of forest area just since 1990 in North and South Korea. Now remember, South Korea is still in development. They're still, you think of South Korea still like 30 years behind the US in terms of development. This is forest area in North versus South Korea. So you think communism is good on the environment? Just in the last few decades, they're completely destroying their forests. South Korea is flat. My prediction is at a later stage of development that line will go up for South Korea, and here's why. Something called the environmental Kuznets curve. And so I want you to think about this sort of intuitively. Let's say you're that mother in Namibia living in a mud hut using dung to keep your children warm. How concerned are you about the parts per million of sulfur in the air? Right? At all? Do you care? No, you don't. You want to make sure your children don't get killed by poisonous snakes, they don't freeze to death, and they don't die of diseases that we solve for $3.50 at the drugstore. That's what you're worried about. And so when cultures are at very early stages of development, they tend not to be worried about exactly how clean the air is, exactly how clean the running water is. But you know what happens is that countries get more and more rich in terms of per capita income, they get more and more interested in environmental stewardship and these questions. And so this results in what's called the environmental Kuznets curve. So if you look here on the vertical axis, this is environmental degradation. On the horizontal axis, per capita income. And this is essentially what you see. In early stages of development, the environment's pretty bad. Nobody seems to care. You reach a certain stage, and then it actually starts getting better. We reached that stage several decades ago. Some countries like China, I think, are probably just now getting there. And so my argument would be, if you're actually interested in environmental stewardship, if you're interested in actually helping people in the poor in the developing world mitigate and adapt to environmental change, whatever is causing it, then you ought to work for policies that actually increase the amount of economic freedom that people enjoy. Because that's ultimately, that's what we're interested in. And I'll close with a quote from Laudato Si and Pope Francis, who puts it this way. He said, look, if you actually want to make a case for environmental stewardship, you need to dignify human beings. And here's how he puts it. He said, human beings cannot be expected to feel responsibility for the world unless at the same time their unique capacities of knowledge, will, freedom, and responsibility are recognized and valued. Thank you very much.